Hi, my name is Gil Gonzalez, and this is my VFD Training Center project. Here are some pictures of how the project went, how it all started when we had all the equipment up, when we started wiring, and this is the final product. I will now show you my CAD drawing. I have a layout of the components and everything that the pictures just showed you. I also have the disconnects and how they're wired, along with the control center. As you can see, there all the wires and everything showed how the push buttons are connected. I also have the 120, which you can see here, and this is my distribution center for the 480. This would be one of the Kinetics servo drives that one of my classmates was working on, and we have my PLC here. This is the switch, the control center, and as you can see, everything has its own terminal block. So each VFD gets its own terminal block, and so does the control center, as well as the disconnects. Each one has its own terminal block. Here's my power supply, and it's going to be feeding the PLX 31 ProSoft. Also, as you can see, there's two motors, one's a 480 and the other one's a 240. And each PLC has its own terminal block to be connected to the motors. So you can use whatever VFD you need. I did a drawing for each drive with its parameters, but I'm not going to bore you with that. It's pretty much looks the same, and we will talk more about it later in the owner's manual. I'll speed it up so we can get through faster. This is the owner's manual. As you can see, we will talk about all the VFDs that we saw on the AutoCAD. The introduction goes on the following pages. We'll introduce you to a set of VFD drives from different brands and voltages. You will be able to see what parameters need to be changed to run a motor forward and reverse. Most of the parameters are set to either run 2-wire setup or a 3-wire setup. The purpose of this manual is to introduce and help you better understand the VFDs. We'll start with the Omnitron 3G3MX2. At this point, I'm going to speed up the video, and if you need to pause it to look at the parameters on one of the VFDs, you're more than welcome to. I also added a diagram of the VFDs so you know what needs to be connected once you want to wire the VFD. The next one is going to be the PowerFlex 40. This one's one of my favorites. It's a lot easier than most of them just because the parameters are a lot easier to read. And it's got a better manual on it, I think, in my opinion. And like I said, there's a diagram that explains how to connect them, which is really helpful. Those are the only two VFDs that we have for 480. Next, we have the 240 volts. The Altivar 58 is not one of my favorites. Its parameters are just a little bit hard to understand. Plus, on the other hand, has all its parameters right where you need them, one right after the other one. You don't have to go and look all over the place for them. You finish with one, and the next one is right next to it. Even the diagram for the wiring is a lot easier to understand than the other one. The Softronic, I don't know what to think about it. It's not that hard to program, but once you get to the wiring part, it's kind of difficult because it's not really clear about it. The Altivar 31 is the same thing. The parameters don't make any sense to me, but once you start getting it, you don't start making sense of them, you just go and look for them. So it starts to get a little bit easier. The wiring, though, I can't really complain. It's really self-explanatory, and it's not really hard to do. The ATB12 is the only one that I have that it's 120 volts, and it's the one that I chose to do Modbus on it. I decided to do this one because it was the first one that I saw. I took a page out of the owner's manual to put there to make it easier. The only thing that I had a problem with was the owner's manual said to change the channel to TER instead of Modbus, and I wasn't getting any results until I changed it back to Modbus. This is my ProSoft. I had to download the ProSoft configuration builder in order to make this work. I also changed the enable to yes, the RS interference to RS485, the type to master, the protocol to RTU, and I made sure that the bound ratio was the same as my VFD. After that, go into Modbus port 1 commands. That's where you will do the commands for the PLC program. It's very important that you remember that inputs start at 0 and outputs start at 2000. Don't forget that. It's a crucial thing. Up next is the HMI pages. We'll start with the home page. Here you can log in and out of the system and even shut down the program. I had 2 usernames. I listed them down: supervisor, maintenance, and operator, along with their passwords and what kind of access they have and to where they can go. As you can see in the home page, you have access to every other window on the program. This is the control page. This is where you can control the motor. You can either make it go forward, reverse, change the frequency on it, make it stop, and even reset the VFD if it's ever faulted. You can see you can also move from this page to any other page just with a click of a button. The next page is the motor page. Here you will be able to see the status of the motor, if it's running or if it's shut off, and you will also keep track of the hours and minutes that the motor has been running. There's a timer reset for whenever the maintenance people do a PM or they checked it, see if everything's okay. Next page is the alarms page. This page will keep track of all the alarms and faults if there ever is one. And last but not least is the trend page, which will keep track of the VFD's current and the frequency. Up next is my PLC program. As you can see right away, I just have subroutines. First one is controls, the next one is timers, and the other one's alarms. And the controls area is what makes the motor run. Basically, this VFD needs to be enabled, and that's what the first command is. Put a 14 in the word base to make it enable. After that, we can either make it go forward or reverse by putting another number into the word base. For forward, you need to put a 15, and for reverse, you need to put a 2063. For the stop button, you just need to put a 0 in front of it. The rest of the program I have is the speed. I have it multiplied by 10 because you need to put a bigger number into the VFD to make it run. So we'll do a 30 in the HMI, but in the VFD we'll be writing a 300. And it's going to be the opposite for the VFD frequency and the VFD current, because they get the numbers from the VFD, so we got to make them less, so we're dividing them by tens. Over here I have a bit to let me know when the motor starts running forward and when it starts running in reverse. That way I know that the motor is actually running and not just the VFD trying to make something else. It's a good way to keep track of the motor. I also have the speed set so it doesn't go over 60. This is my alarm bit. The VFD will send me a fault bit if it ever faults. That will trigger my fault bit. And I also have a reset button that will put a 142 into the bit so it will reset the fault. These are my timers. I basically have every time the motor starts running, it'll start this timer. That timer will run for 20 seconds. And once it's done with the 20 seconds, it will trigger the count up. Count up will we'll do 3, and then it will reset. After 3 is a minute. So every minute, it goes down into the next one. And then after 16 minutes, it goes down to the next one. And that's how we get our hours and our minutes. And I have an HMI button that will reset that. And that's what we just saw in the motors. Now let's try the whole thing and see how it works. As you can see here, this is the login. We'll put supervisor on there to make sure we get access to everything. We'll do our password. And hit enter. Now we should have access to everything. We'll go into the control set. As you can see, it's reading the frequency right now. The motor's not running, but it's set to 45. We'll hit the forward button, and the motor starts right away. As you can see on the screen, there's a motor that says motor running forward, and it's green. As soon as you hit reverse, the motor stops and it starts going in reverse. And as you can tell, the motor is now going in reverse. You can always change the motor frequency, which is the speed. Go to 35 and the motor starts being slower. Go up to 55 and it'll go faster. And as you can notice, the motor's always running, and you can see the color. It'll be blue for reverse, green for forward. You can see how the motor's running. It'll be in a green state and how much the minutes are going. This is the alarm page. We don't have anything. This would be our trend. As you can see, it's measuring the current and the frequency, keeping track of how they're acting. And back to the control page so we can see if it stops. And there it goes. As you can see, the motor disappear along with the letters on top. Well, that's it for me. Thanks for watching.